All right, here we go. We're going to work on our test review. So this is for the test over rational expressions. First, we'll find the domain. So in order to find the domain, we're going to set the denominator equal to 0. And then those are our restrictions. So we have m squared minus 49 equals 0. This is a difference of two squares. So we factor it by using the conjugate. So we have m minus 7 equals 0 and m plus 7 equals 0. So m cannot be 7 or negative 7. Those are our restrictions. And here's how I want you to write your domain for the test. Negative infinity. Next biggest number is negative 7 to positive 7, and then 7 to positive infinity. Okay, so this is what I want you to write down for your domain. All right, next one. Same thing, we're going to set our denominator equal to 0. We'll factor here. So we have m minus 9 and m minus 10. What multiplies to get 90 and adds to get negative 19? We have m minus 9 equals 0 and m minus 10 equals 0. So m cannot be 9 or 10. All right, so here's your domain. Start with your smallest number, that's negative infinity. Then your next smallest, which is 9 to 10, and then 10 to positive infinity. Okay, so that's your domain for number 2. Number 3, same thing. Set your denominator equal to 0 and solve. So x equals negative 9. So x cannot be negative 9. That makes it undefined. So our domain is negative infinity to negative 9, and then negative 9 to positive infinity. And that's your answer for number 3. I'm not asking you for wholes or asymptotes, just the domain, okay? So you don't have to tell me whether it's a whole or an asymptote. So x here or k here cannot equal negative 7. And your domain is negative infinity to negative 7, and then negative 7 to positive infinity. Easy enough, right? All right, on 5 through 10, we're going to simplify. So we're going to remember our tips are factor, factor, factor. So we're gonna factor the bottom. The top is already in a factor form. So I ask what multiplies to get negative 30 and adds to get negative 1. I get negative 6 and 5. Looks like our x plus 5s can cancel. If you cancel everything on the top, you have a 1 left. So it's 1 divided by x minus 6. All right, let's factor here. I'm going to do the a times c method. So I'm going to do 2 times 10, that's negative 20, and see, okay, what multiplies to get negative 20 and adds to get negative 8? Negative 10 and 2. So we're going to split our middle term, 2x minus 10x plus 2x minus 10. Group our first two, group our last two, pull out a 2x here. So we have x minus 10, pull out a 1, because we can't, or a 2, I can pull out a 2. This is 5. Oh man, that's a 5. Pull out a 2, so this is x minus 5. So we have 2x plus 2 times x minus 5. That's the numerator. 2x plus 2 and x minus 5. And then I'm going to, oh, look what else we can do. We can factor out a 2 here. Factor, factor, factor. Keep factoring until you can't factor anymore. All right, I'm running out of room. Same thing here. I'm going to multiply a times c, we get 70. So what multiplies to get 70 and adds to get 17? I'm going to say 10 and 7. So I have 7x squared plus 10x plus 7x plus 10. Group our first two, group our last two. Pull out an x here, 7x plus 10. Nothing can be factored, so I pull out a 1 here. I'm messing up on this one all over the place. 7x plus 10. So my factored form is x plus 1 and 7x plus 10. This should be x plus 1 here if you factor out a 2. Sorry about that. All right, so my answer, where am I going to write it? 2x minus 5 divided by 7x plus 10. That is your final simplified answer. Can't be factored anymore. You're done. All right, let's look at the next one. That probably needed a bigger box. What multiplies to get 16 adds to get 8? How about 4? So I have 2 n plus 4s on the bottom. I can only cancel out one of them. If you have nothing else on the top, it stays a 1. So I have 1 over n plus 4. Go back and forth between boxing and circling. All right, next one, p plus 9, that's already in factored form. What multiplies to get negative 9 adds to get 8. We have a p, plus 9 and p minus 1. They cancel. If you have nothing on the top, it's a 1. P minus 1 is your answer. 1 divided by p minus 1 is your answer. All right. This one down here, what can I factor? Well, I can factor out a 2. I'm going to use another piece of paper because I just know that I'm going to run out of room. So this is number 9. 2x squared plus 14x plus 24 divided by 6x squared plus 27x plus 12. So I know in my numerator, I can factor out a 2. So I'm going to do that first. 2x squared plus 7x plus 12. And here I can factor out a 3 in the denominator. So I have 2x squared plus 9x plus 4. So now on the top, I'm going to factor it. What multiplies to get 12 and adds to get 7? I would say 4 and 3. And then on the bottom, I'm going to do the a times c method. 4 times 2 is 8. So we say, okay, well, what multiplies to get 8 and adds to get 9? That is 8 and 1. So I split my middle term into 8 and 1. Group my first 2, group my last 2. Don't forget that 3 is still there. I can pull out a 2x here. So I have an x plus 4. I can't pull anything out here, so I pull out a 1, and it's an x plus 4. That 3 is still there. So I have in the denominator 2x plus 1 and x plus 4. Right now I can cancel. I've factored completely. So this cancels. And that's it. So my answer for number 9 is what's left over is a 2 and an x plus 3 and a 3 and a 2x plus 1. That's your answer. All right, number 10, I'm going to do on paper as well. So this is number 10. We have 3x divided by 7x squared. Now I'm going to write it like this because this line here means divide, right? You will have one like this on the test, divide. So I'm just going to write it like this, divide horizontally. Help us think about it a little bit better. Divided by 18x plus 6. All right, now we're going to factor. And how do we factor rational expressions? I mean, how do we divide rational expressions? We multiply by the reciprocal, right? So this becomes 3x divided by 7x squared times 18x plus 6 divided by 9x squared plus 3x, right? Can't factor anything here. So I'm just going to rewrite it. I can factor out a 6. So I have a 3x plus 2 plus 1. Oh. And I can factor out a 3 here, 3 and an x. So we have a 3x plus 1. Nice. All right. So, hey, there's a 3x plus 1, 3x plus 1. I got a 3x and a 3x. I have a 6 and a 7x squared. I don't have another x to cancel, so my answer here is 6 divided by 7x squared. So that's your answer for number 10, 6 divided by 7x plus 6 divided by 7x squared. Take it one step at a time, okay? Go slow. All right, next page. We're still simplifying. So this one has 4 terms. In order to factor something with 4 terms, I'm going to do factor by grouping. Let's see what we can pull out of here. I can pull out a 2 and a k squared. So I have a k minus 3. I can pull out a 3. So we have a k minus 3. They match. So factor by grouping is 2k squared plus 3, and then a k minus 3. And then here, same thing, factor by grouping. What can you pull out of here? You can pull out a k squared. Then we have a k minus 3. Can't pull anything out of there, so you pull out a 1, and you have a k minus 3. So we have in the denominator k squared plus 1 divided by k minus 3. So those cancel there. So it looks like my answer is going to be 2k squared plus 3 divided by k squared plus 1. Don't let that trip you up. This is not a difference of 2 squares, so I can't factor that any further. All right, I feel like I keep running out of room. So on number 12, I'm going to do it right here. All right, number 12 says 6 minus b divided by 4b squared minus 24b. And this is another one of those divided. So I'm just going to write it horizontally. 1 divided by 5b plus 15. So let's multiply by the reciprocal. So it's 6 minus b divided by 4b squared minus 24b times 5b plus 15 divided by 1. All right, so now let's factor. This one's already in factored form, 6 minus b. Here, I can pull out a 4 and a b, so we have a b minus 6. And then here we can pull out a 5, and we have b plus 3 divided by 1. All right, so it's looking kind of funny. I want to pull this out, don't I? Because I want these to look alike. They don't look alike yet. I can make them look alike if I pulled out a -1. If we pulled out factored out a -1, what does it do? It switches the signs, right? So if I say that this is 6 minus b and I pull out -4b, then that makes that -b plus 6, which is totally fine because now they cancel. Nothing cancels up there. So on the top, we have 5 times b plus 3. And in the denominator, we have a -4b. Don't forget that negative sign. We do that right. Yes. All right. So that is your answer there. For number 12 is, and you don't even have to multiply it out. You can leave it like that. 5b plus 3 divided by -4b. Done. All right, next one is perform the operation and simplify. You do not need to state the domain. So what we'll do on 13 is we're gonna factor, right? So let's factor first and see what we can cross cancel. So here, let's pull out a 9k squared, and we have a k plus 6 left. And then this is a difference of 2 squares. So I know it's k plus 6 times k minus 6 divided by k minus 6. So anything on the top can be canceled with anything on the bottom. K plus 6's can cancel, k minus 6's can cancel. So I am left with, multiply straight across, a k minus 7 on the top over here and a 9k squared here. That's it. I cannot cancel my k's because it's being subtracted, right? It would have to be multiplied or divided. So k minus 7 over 9k squared. That is your answer. All right, dividing, we know we have to multiply by the reciprocal of the second number. So we are going to write it down. 1 divided by n plus 9 And I'm going to go ahead and multiply 6n squared plus 54n divided by n plus 3. All right. This is already factored. This is already factored. Let's factor this top expression here. So I have 1 over n plus 9 times, can pull out a 6n, and I have an n plus 9. That's nice. Divided by n plus 3. So all that cancels is those. These cannot cancel again because we are adding here, so we can't cancel that. So your answer is 6n divided by n plus 3. Okay. All right, here we're multiplying straight across, but I'm going to factor first. These are already in factored form, but I'm going to factor this. So we have 1 over x minus 2 times 3x plus 6 over x plus 6. Look at that, those cancel, multiply straight across, 3 divided by x minus 2. That's your answer. All right, next one we're dividing. So we're flipping the second, or we're multiplying by the reciprocal of the second number. So we have times 4r squared plus 4r divided by r plus 1. You can factor at the same time as flipping. You don't have to do it in so many steps like I am. So we have 4r. I know I can factor out of 4r here. And we have r plus 1. That's nice. R plus 1. You can already see that these are matching. Those are matching. I have nothing on the bottom, which means it's a 1 over 1 just as itself. And we have an r plus 8 on the top, so you can leave it like that. All right, next one. Multiply straight across. These are already in factored form. So we're going to factor this one, x minus 3, 9, x minus 6, plus 6. Ooh. I'm going too fast. X minus 1 here. All right, so my x plus 6 is canceled. We have an x minus 3 divided by 9 times x minus 1. You don't have to multiply it out. Just leave it like it is. It's fine. All right, next one, we're dividing. If this is feeling tedious and monotonous, that's good because that means you're understanding it. So make sure you're trying these on your own before watching the video, and then you can kind of correct. All right, flip and multiply. I am going to go ahead and factor what multiplies to get 72 and adds to get 17, negative 8, negative 9, times, I'm going to pull out a 4, pull out a 4 in, so we have an n plus 5 divided by n plus 5. That's nice. So these cancel. Oh, that stinks. Nothing cancels over here. So we have 4n divided by n minus 8, n minus 9. Just leave it like that. You don't have to multiply it back out. It's totally fine. Right, next page. There is one like this on the test. It's a little bit of a doozy. These are being multiplied so they stay. The only thing that you really have to do is multiply by the reciprocal here. So I'm going to factor and do the reciprocal at the same time. So what multiplies to get negative 6 adds to get negative 5. I'm going to say negative 6 and positive 1. And x minus 9 on the bottom. So we have times. I can pull out a 6x here. So we have an x plus 4. And then I'm going to pull out this negative, see if that does anything. So I have an x plus 1 here. And then we're multiplying. The negative 2 goes to the top. So we can make those both multiplying with x's. And then what multiplies to get negative 24 adds to get negative 2. I'm going to say negative 6 and positive 4. All right, anything on the top can cancel with anything on the bottom. So those cancel. I got a 4 that cancels, x plus 4, and an x minus 6 that cancels. You have to think about this all as 1, so it can't cancel with that. And now I'm just going to multiply straight across. So we have negative 12x on the top. And then don't forget that negative 1 and an x minus 9 on the bottom. So that is your final simplified form. All right, next we're moving to radical equations. So remember your steps for radical equations. We're isolate the radical first. I know we were missing that. Isolate the radical first. So remember to isolate the radical first, and then you're going to raise it to the nth term. So it's the opposite value. All right, so this first one, we have radicals on both sides and they're both isolated. So I'm going to square both of them, and that's great because that cancels everything here. So we have 8 minus r equals 2 minus 4r. Now I just solve it like a regular equation. I'm going to add the 4r over here and subtract the 8. So we have a 3r equals negative 6, divide by 3, and r equals negative 2. Now it tells me, be sure to check for extraneous solutions. So I need to make sure that this negative 2 is actually an answer. I didn't really give myself very much room. So I have negative 8, or 8 minus a negative 2 equals the square root of 2 minus 4 times negative 2. So I have plus a positive, that's square root of 10. And then negative 4 times 2 is 2 plus 8, and that's 10 as well. So we check out. We're good. All right, next one. My radical is isolated, so we're going to square both sides because it's to the square root. So we have k squared equals 9 plus 8k. I see a k squared and a k, so I'm going to get everything on one side and factor. So we are going to subtract 8, subtract 9. So we have k squared minus 8k minus 9 equals 0. What multiplies to get negative 9 and adds to get negative 8? It's going to be a negative 9 and a positive 1. All right, so we have k minus 9 equals 0, k plus 1 equals 0, k equals 9 or negative 1. All right, so now this is probably one of those where we need to check for extraneous solutions. So I'm going to plug the values back into my original equation. So we have 9 equals the square root of 9 plus 8 times 9. So let's see if this is right. Square root, 8 times 9 is 72, plus 9 is 81. So that's correct. Okay, let's look at negative 1. Negative 1 equals square root of 9 plus 8 times negative 1. All right, 8 times negative 1 is negative 8. 9 minus 8 is 1. But see here, you can't take the square root and have a negative number. So negative 1 is not a solution. Only 9 is a solution, right? Make sure you're checking for your extraneous solutions. All right, radical is isolated. I'm going to square both sides. So that cancels those. So we have negative 49 plus 14x equals x squared. I see an x squared and an x. I'm going to get everything on one side and factor. I always like to make sure that the x squared is positive. So I'm going to subtract 14 and add 49. So we have 0 equals x squared minus 14x plus 49. Factor. So we have x minus 7, x minus 7. So x equals positive 7. I'm just going to write it once, even though it has a duplicity of 2. So we have negative 49 plus 14 times 7 equals 7. So 14 times 7, I'm guessing that is what, 98? Yeah, so it ends up being positive 49. And that works. So that checks out. Yay. All right, next one. My radical is here. I have this 5 plus over here. So I'm going to subtract the 5 here, and we have m minus 5 equals square root of 4m minus 23. So now my radical is isolated. We can raise it to the second power. Remember, m minus 5 squared is m minus 5 times m minus 5. And then that cancels there, so it's 4m minus 23. We're going to FOIL. So we have m squared minus 10m plus 25 equals 4m minus 23. I'm going to get everything on one side and try to factor. So this becomes m squared minus 14m plus 8, 48. So what multiplies to get 48 and adds to get 14? I say negative 8 and 6. And so m equals positive 8, and positive 6. Let's see if either one of these works. I'm not sure. So we have 8 equals, we'll try 8 first. 5 plus the square root of 4 times 8 minus 23. So that's 32 minus 23. 32 minus 23 is 9. Not the square root of 9 is 3, and 5 plus 3 is 8. So that works. All right, let's check the other one, 6. So I have 6 equals 5 plus the square root of 4 times 6 minus 23. So 4 times 6 is 24. 24 minus 23 is 1. Square root of 1 is 1. So 5 plus 1 is 6. Hey, they both work. All right, so I'm going to box both of them. I mean, it seems like there's a pattern if it's a negative number. Sometimes the negative numbers aren't working, but just really depends. You got to plug it back in. All right, the next one, number 24. My radical is not isolated, so we need to add the 18 to the other side. So we have the square root of 2x minus 8 equals negative 16 plus 18 is 2. We're going to square both sides. So we have 2x minus 8 equals 4, and then just solve it like a regular equation. No need to factor on this one. So we have 2x equals 4 and x equals 2. Let's plug it back in, see if it works. Square root of 2 times 2 minus 8 minus 18 equals negative 16. So we have 4 minus 8. Ooh, maybe this doesn't work. Is the square root of negative 4. So this is no solution, actually. Interesting. Because the 2 doesn't work. So I'll show you in just a second. I'll pull up Desmos and show you what that looks like on a graph. Let's do the next one first. All right, let's square both sides. So we have 28 minus 4v equals v minus 7 times v minus 7. Remember, it's foiling. So we have 28 minus 4v equals v squared minus 14v plus 49. We have a v squared and a v, so let's get everything on one side and factor. I'm going to add the 4, subtract the 28, so we have 0 equals v squared minus 10v. What is that? 1, 2, 21? Yeah. All right, so we have what multiplies to get 21 and adds to get negative 10. I say negative 7 and negative 3. That's nice. So we have x minus, oh, I just totally changed it to x. That's okay. I'm just going to roll with it there. So x equals 7 and x equals 3. All right, let's see which one of these, if any, work. We have the square root of 28 minus 4 times 7 equals 7 minus 7. Oh, 0, okay. Well, 28 minus 28 is 0. So that does work. All right, let's try 3. 28 minus 4 times 3 equals 3 minus 7. 4 times 3 is 12. 28 minus 12. 28 minus 12 is 16. Yeah, 16 equals negative 4. This isn't going to work because you can't have it equal negative number. So 3 doesn't work, only 7. Nice. All right, last page. I remembered this time. Now we have some higher powers. 26. It's isolated over here. We haven't really done one of these in class, but that's okay. I think you'll be fine. So we have the square root of x minus 2 squared, which means we have to FOIL, equals x minus 6. That already pops out. Those cancel, right? I don't know what's going on. All right, so we're going to FOIL first. So square root of x times square root of x is square root of x squared. So that x just pops out. And then I have negative 2 root x, negative 2 root x plus 4. So we can combine our like terms here and have x minus 4 root x plus 4 equals x minus 6. So the issue is here, like now we have another radical, so we're going to isolate it again. So we have, let's put our x on the other side and subtract our 4. So we have negative 4 root x equals, those cancel, negative 10. This isn't too bad. divide by -4, and we have the square root of x equals 5/2. Square both sides, and we have x equals 25/4. That's one that I'm going to check in my calculator. Let's see if 25/4 works. So I have the square root of 25 divided by 4 minus 2. That's 0.5. All right, so let's see the square root of 25 divided by 4 and minus 6 is 0.5. So it checks out. So we're good to go there. You can always use your calculator. You will have access to your calculator on this test. All right, so let's isolate our radical first. So we have 10 cubed root of x minus 5 equals 3. Divide by 10. So we have the cubed root of x minus 5 equals 3/10. We'll cube both sides. And so now we have x minus 5 equals 27/1000. Nice. Then I'm going to add 5. Okay. So this becomes, what's 5/1? And I'm going to change that so I have 5,000/1000. That's funny. So we have x equals 5,027/1000. That's a weird number. Let's check and see if it works. So we have 2 plus 10 times the cubed root of 5027 divided by 1,000. One more 0. Minus 5. And it equals 5. So we check out. That's nice. All right, let's keep going. 28. Saying the 28 is very much like 26. So I would go and try this one first and then come back and check. So we're going to FOIL, like follow the steps as 26 and then check to make sure that you got it right. All right. So we have x pops out there. We have a negative x squared or root x and then plus 1. Combine our like terms. So we have x minus 2 root x plus 1 equals x minus 3. Move the x and the 1 over. So we have -2 root x equals, those cancel, -2, divide by -2, and looks like a positive 1. Square root of x equals 1, square both sides there, and x equals 1. Let's plug this back in to make sure that it works. Square root of 1 minus 1 equals square root of 1 minus 3. Square root of 1 is 1, 1 minus 1 is 0. Ooh, it does not work, does it? 1 minus 3 is -2. Nope. So this one is also no solution. Bummer. Thought it was going to be better. Square both sides here. We have 2x plus 1 equals 3x. Let's put our x's on one side. So I'm going to subtract the 2x. 1 equals x. Nice. Oh, let's plug it back in. Sorry. 2 times 1 plus 1 equals square root of 3 times 1. So 2 plus 1 is root 3. We got root 3. Works. We're good. All right. Next one is cubed root. Isolate your radical here. So I'm going to subtract 1. I did notice that many people were struggling with knowing that this is multiplication here. So you have to make sure that you divide. So we have 8. So let's divide by 4. So we have the cubed root of x minus 2 equals 2. Cube both sides. So we have x minus 2 equals 8. Add 2. And x equals 10. Let's make sure this works. So 4 times the cubed root of 10 minus 2 plus 1, does that equal 9? 4 times 10 minus 2 is 8. The cubed root of 8 is 2. Plus 1, does that equal 9? Yeah, it does, because 4 times 2 is 8 plus 1 is 9. All right, nice job. All right, next one, number 31. We're still isolating, so all of this we have to get our variable, right? So 80 equals negative 10c cubed. Divide by negative 10. That's negative 8 equals c cubed. And the opposite of cubing is taking the cubed root. So we're going to take the cubed root of negative 8. Remember, you can multiply a negative 3 times and still get a negative. So there is a negative cubed root to negative 8, and that is negative 2. So negative 2 equals c. Next one. Add 10 to both sides. So we have 3 equals 3a cubed. Divide by 3. You're still isolating your variable. A cubed equals 1. Take the cubed root just like last time. Cubed root of 1 is 1. All right, last one. Here we go. Subtract 1. We have negative 162 equals negative 6m cubed. Divide by negative 6. That's positive 2. Is that 4 left? Oh my goodness, 27 equals m cubed. Cubed root of m cubed is 3. M equals 3. Nice work, everybody. If you want some extra practice, I would say work on the take-home test on these parts, and that will help you a lot.